In this video we're going to be talking about compound interest and depreciation. Now what compound interest is, it's found with the repeated use of the simple interest formula. So if you do the compound interest once, it's the same as what would happen if you use the simple interest formula once. However, if you did the compound interest to the power of, say, 2, which we'll get to in a second, that's like doing the simple interest formula twice, and so on and so forth. So first of all, now we have that idea down, we'll talk about the formulas. So there's 3 formulas I want to talk about. The first is the compound interest formula. This is A is equal to P outside of 1 plus R all to the power of n. Now the compound interest formula and depreciation formula are very similar. The difference is there's a plus here and there's a minus here. That's because this value is increasing, this one's decreasing. Now this is a different idea to the simple interest formula, is that it's equal to A, not I. So to find I, we need to get the answer of A and subtract the P, which is what we started with, which gives us this formula here, that interest is A minus P. Now down here I've got a list of what all these letters mean. A is the final amount, P is the principal, which is the initial amount, the amount we start with. R is the rate, normally it's in a percentage. Then N is the number of periods, and I is the interest. So we can use that idea with the formulas up here. So let's put this idea to practice. But first, before we go jumping straight into using our formulas, we have to make sure that our rates and time periods are the same. So in this first example, we have 6% per annum over 4 years paid monthly. Now the issue here is PA means per annum, that's going to be yearly, and 4 years, that's in years, and we need it in months. So as we need it in months, we need to do some converting. So now, the way we'll convert this, first of all, we'll identify some things. So I'm going to change to red here. This is our rate. This is our N. And we don't care about our P right now because we're just converting some things. We're not actually using this formula. This is all they've given us. We need to make sure our rate and N are in months, not years. So the way we do this is, as this is the percentage per year, we need the percentage per month. So to do that, we're going to take the rate and divide it by 12. So here it's going to be 6% divided by 12. Now when I type this into my calculator, I'm going to exclude the percentage symbol. The reason why, I'll show you. If we do 6% divided by 12, it gives us this answer here, which is a decimal. The calculator won't give us an answer as a percentage. So I'm going to remove the percentage and you'll see what happens. We get 0.5. That tells us that 6% divided by 12 is 0.5%, which, if we did 0.5% in our calculator, is the same as when we included the percentage symbol in the calculator. So if you want to use a decimal, you can pop it straight in like this. However, if you want to keep it as a percentage, I like to do it like this, excluding that percentage symbol in the calculator. Now for our N, this is 4 years. Now we know that if we had 1 year is 12 months. So we need to do our N and multiply it by 12. So in this case it's 4 times 12. We'll type that into our calculator. 48. So we've got 48 months, and our percentage is per month. And that's how we get it. Now, for our rate and our number of periods, you always, assuming you're starting with years, you're always dividing the rate by whatever you're converting to and timesing the N by whatever you're converting to. We'll see that example again here. So in this part, we've got 18% per annum, which is our rate, over 3 years, which is our N, and we need to get quarterly. So when it's quarterly, that means there's 4 quarters in 1 year. So we'll do the same thing, but this time instead of dividing by 12 and timesing by 12, we're going to do our rate divided by 4 and our N times by 4. So here we've got 18% divided by 4, which again, when we type it in the calculator, I'm going to ignore the percentage symbol. we get 4.5, and we're going to add the percent back in, 4.5% per quarter. And for this one, we've got three years, so 3 times 4 gives us 12. 3 times 4 gives us 12 quarters. So once you do that, you're now ready to input that information into the compound interest or depreciation formulas. So we're going to practice that now. Okay, so the first thing we're looking at when interpreting a question to apply our formula, using the compound interest formula, it says determine the amount after 5 years if $4,000 is compounded annually at 8%. Now, aside from a couple of key words, you don't know necessarily if this is a compound interest formula question or a simple interest formula question. However, as it says compounded, that tells us it's the compound interest formula. That's the key word there. So, as we're aware of this, I'm going to rewrite the formula so we can help remember. So it's A equals P inside of 1 plus R to the power of N. So, for this question, our P is $4,000. That's how much they start off with. The R is 8%. Because that's the percentage that it's compounded at, and it's over 5 years, so that's our N. And it's compounded annually. So we've got our percentage and our time both in years, so we can put it straight into the formula. So when we do this, we'll write it first. We've got our A is equal to 4,000 inside of 1 plus our rate is 8%. To the power of N, which is 5 years. So when we type it into our calculator, we've got 4,000. And you can do times. If you don't do times, the calculator still knows that when there's brackets, it's being multiplied. We have 1 plus 8% to the power of 5. We'll get our answer. It's $5,877, and we'll just go to 2 decimal places because it's cents. That's 31 cents. So that's how much they'll finish with at the end of the time. Alright, we'll do another example. This time it says using the compound interest formula with months. So that's the key there, that we're going to be doing it with months, converting some time, just like we did in the first example. So Tony's investment of $4,000 is compounded at 8.4% per annum over 5 years, paid monthly. So, first of all, I'm going to rewrite the formula just to remind ourselves what it is. And I'm going to write down what we know. So, we know the P is 4,000. We know that the R is 8.4% per annum. We know that the N is 5 years. Now here the issue is that it wants monthly, and we've got years and per year. So we need to make some changes here. So just like in that first example, we're going to have to fix this up. So our rate, we're going to, as we're doing it into months, we're going to divide our rate by 12. And we're going to times our N by 12. So that's 8.4% divided by 12. And if we type that into our calculator, as before, I'm going to ignore the percentage symbol for the moment. 8.4 divided by 12 gives us 0.7. So our rate is 0.7% per month. Now our N, we've got 5 times 12. Popping that into our calculator again, we've got 5 times 12, that's 60. So that means we've got 60 months. So now we've got our N in months and our R in per month. We can then put these into the formula that we've written up here. I'm going to do that up here just so we have a bit more space. So A is equal to P, which is the same, it's $4,000 times 1 plus, now instead of using 8.4%, I'm going to use 0.7%, as that is a monthly percentage, and it's to the power of 60, not 5, our new rate, new n, which is 60. Once we've got all that, we pop it into our calculator. We've got 4,000 inside of 1 plus 0.7% to the power of 60. That gives us $6,000.78, and we'll round up, that's 95 cents. So that gives us our answer for example 3. So making sure that our R and our N match the rate in which is being paid. Our final example, we're going to look at depreciation. So here, Steve's car, which was bought for $22,000, loses 15% in value after a year. How much is it worth after 4 years? So I'm going to rewrite the formula just to get some practice. We've got A is equal to P inside of 1 minus R to the power of N. Remember, it's minus because it's depreciation. And I'll write over here the information that we know. So we know that it started off at 22,000, that its rate is at 15% per year, so that's PA. And our N we want to know after 4 years. Okay, so we've got the right rate we want to know after each year, as it says here, and the rate is already in years, and the amount of time is in years as well, so we can put it straight into this formula. A is 22,000 side of 1 minus our rate, which is 15%, to the power of 4. We'll pop it into our calculator. 22,000 side of 1 minus 15%, all to the power of 4. And there we go. So it started off being $22,000, and now it's worth $11,484.14. So there we go.